Hi, my name is Bill Habermann from InterTest Incorporated. Here is our MZ5 FS in a configuration optimized for 120mm tube inspection that is using high-definition video sensors, side view and forward view, white light and UV light, presented on a 27-inch monitor using DocuView, our GUI for interacting with a system of this nature. And in this particular application, we use a cantilevered support slide, a motorized slide, that allows manual translation. We disengage the motor, or with the motor engaged, motorized translation. The system, as a cantilevered boom, means it's contactless. There's no centering fixture touching the target. So contactless is a very advantageous method of reaching into a tube. To make that work, several things come into play. One is we need a very stiff and lightweight tube. So this construction is a carbon composite tube. You'll note we have distance markings, and if you looked at the other side, there are markings in metric units as well as imperial units on this side. So that lightweight tube is stiff, and it minimizes droop. It's inevitable with any device cantilevered, no matter what it is, there will be some droop. It's a matter of degree. So each carriage has a gimbaled fixture to hold on to the MZ5 tube, so that can twist, and each carriage has a scissor lift. The scissor lift allows us the ability to tweak each side up and down, resulting in that end translating horizontal and moving on a completely flat, very robust rail. So the system is a robust, linearly actuated inspection system. We're going to operate the system in the manner that a person in the field would operate it, and look at a sample tube, which is placed on a counter over there. We have a motion control or motor controls, and we're allowed to insert, and we can control speed with a slider and a soft key. Right now we're seeing our carpet go by on the floor. This sample tube is 120mm. It's a rough machine version of the end product, or a segment of it. It's loaded with material that is fluorescent. So this is really much more fluorescence than would be typically visible in an inspection scenario. It's not unusual in some inspection scenarios to want to take a view down tube and get a kind of a macro view or overview of your target area. So in this case, if we go into this tube from with the forward view, and let's turn on a little UV to make it interesting. So now we're looking with ultraviolet light in the down tube scenario, and this is what an operator would see. So for example, in the real scenario, there may be things like linear indications such as this or this. This is how an operator would make that quick overview and identify specific indications, identify the locations of those, and maybe look to do a much more enhanced or detailed evaluation with the side view camera of those particular indications. This is the U.S. Air Force 1951 resolution chart. It's fluorescent negative. It goes to quite a fine gradation in here. It goes to group 7, which is remarkable. You need a microscope to see that with your naked eye. We'll see it better in detail on the system. The MZ5 has some features that are extremely useful, absolutely necessary in many cases. And one of those is focus. So you can see here that we're seeing group 1 element 5, which is the common standard used in a lot of aviation fluorescent penetrant applications. We also have an ability to zoom in the MZ5, and having a 13 megapixel sensor, there is some effective zoom in a digital sense. So we do have in group 2 element 6 the ability to resolve the 3 bars as distinct bars, both horizontal and vertical. So the zoom feature is quite useful. The manual or autofocus is quite useful, and again adds to the ease of use, enhancing productivity of inspection. And certainly with our ability to drive in and out, really makes it an ideal tool for those surface evaluations during magnetic particle testing.